Hi, my name is Hayley Latta, and I'm going to be talking to y'all about coral reefs. As you all know, coral reefs are home to some of the most biodiverse ecosystems on the planet. As you can see here, coral reefs are home to over 25% of all marine animals, while only taking up 1% of the ocean floor. They are home to thousands of species of fish, shark, turtles, and even corals themselves, and all of these animals depend heavily on reefs for protection from predators, shelter, and food. And for this reason, they have been nicknamed the rainforest of the sea. Additionally, they are a huge impact to humans. They protect in over 36 billion from flooding damages, and this, according to the Nature Conservatory, is because the top 3 feet of coral reefs actually aid in breaking up dangerous waves before they become floods. And they hold a huge economic value. As you can see here, coral reefs hold an economic value of almost $30 billion, and this is because they generate revenue for the fishing and tourism industries. Tourists are attracted to reefs because of their beauty, and the fishing industry needs reefs to provide them with fish. However, there's just one problem. According to the Reef and Rainforest Research Center, over 50% of corals are either at risk of dying or already dead, and this is due to a number of reasons: pollution, overfishing, reckless tourism, and carbon emissions, all of which Margaret Thatcher would ascribe to being results of human activity. None of these are intentional. However, they are a result of overpopulation. With an increased population, we have more of a need to have industrial practices that lead to overfishing, pollution, and carbon emissions. So, what can be done to alleviate coral reef destruction? Through my research, I've come up with 2 solutions. The first is artificial reefs. Artificial reefs are man-made structures that are sunk underwater in order to promote coral reef growth. As you can see here, this is an old World War II warship that was sunk to become an artificial reef. It's called the USNS Vandenberg. And as you can see here, some of the coral are kind of building on this part of the ship right here, and it's promoting a lot of fish growth. And there are many benefits to this solution. First, it restores coral cover. With dilapidated reefs, we're losing the amount of coral we have in our oceans. So by introducing an artificial reef to an area, you're automatically getting more reefs and more corals to provide more stuff for these industries. And second, it can be used as a means for recycling. Over 45 ships have actually been sunk in to be an artificial reef, and that's so they can just recycle all these old materials that otherwise would not have been used. However, there are some limitations to this solution. The first is that artificial reefs are very expensive. A report by the University of Florida reports that actually just growing a single artificial reef in just one part of Florida, Northwest Florida, costs the government about $414 million because you need to get these ships vetted and cleared, and then you need to actually sink them. Additionally, artificial reefs have a potential damage. A lot of these old ships actually contain a lot of toxic materials such as asbestos or typical tin. And that's basically comes from the paint in the ships that was actually banned in 1988 because it's so toxic. So this could bring potential harm to the oceans. So I've come to a second solution, and that is coral transplants. As you can see here, this is what a coral transplant looks like. Coral transplants are corals that are taken from a donor reef, raised in a nursery, and then installed into a restoration site, like here. Coral transplants can come in many forms. You can either have an actual coral that's taken or baby coral that's taken. It depends on what research is being done and what the area needs. There are many benefits to the solution. First, it restores reefs. When you have a dilapidated reef, they need more coral to be able to rebuild its structure from the damage caused to it. Like when carbon emissions come, they actually bleach the reef so that they're unable to actually have their color anymore, and they're unable to reproduce. And this leads to my next point in restoring reefs. Coral transplants increase something called coral recruitment. Coral recruitment is the process by which corals actually reproduce. And they reproduce by producing planulae, and then the planulae settles and establish themselves on a reef. They can either stay within the reef that they were produced from, or they can move to another reef. However, most of these baby corals do not like settling on an unhealthy reef, so by increasing the amount of healthy coral in an area, they not only increase the amount of coral in the area, but the amount of baby corals that want to settle there. Second, coral transplants are very efficient. David Vaughn, a marine biologist at Mote Marine Laboratory, found that he can grow an entire coral colony in under 2 years. In nature, this takes upwards of 100 years, so he can significantly reduce the amount of time needed to grow a coral. And third, it's relatively inexpensive. The cost of transplanting one coral ranges from $5 to $20 per coral. However, there are some limitations. The first is, like artificial reefs, they have a potential damage. And this damage is because coral transplants require a donor reef. They require to take coral from that reef, which could stress out the other corals and also decrease their coral cover, which is an issue to many scholars. Additionally, on a global scale, they can actually become expensive. I know I said that one of the benefits of coral transplants is that they're inexpensive, but for large reef restoration projects like the Great Barrier Reef, which measures 2,300 kilometers in length, it actually costs for upwards of $200 billion to repair the entire system. So it has a very big cost that is actually may not be super feasible. But no matter what solution we choose to have, our coral reefs need to be saved. Thank you.
Okay, Hayley. What evidence did you gather that you didn't use, and why did you choose not to use it?
Well, one of my solutions was going to be a carbon tax, and that sort of aimed at, here, I'll show you, my problem of carbon emissions. Here. Sorry. So carbon emissions are caused by like industrial practices, so a lot of people wanted to actually use a carbon tax to sort of reduce this output so that coral reef destruction stops on a whole like global scale instead of just like repairing the reefs. And so that's something I wanted to use. But the reason why I didn't use it is because it had a lot of like economic stuff with it, and it was just a lot of numbers, and it just varied on the information I found. It was kind of hard to get like a super clear response on what's being done because a lot of countries like the US aren't using it.
Okay. Explain the level of certainty you have about your conclusion, solution, or recommendation.
For my conclusion, I'm very certain about it because our coral reefs do need to be saved. They're very valuable to not only our economy, but just about everything else. And so I'm pretty certain about that. And my solutions I really like because they sort of are an immediate solution to reef destruction. They can sort of like, as I said before, they're fairly efficient, so they can just immediately increase coral cover. But it's like, yeah.
Okay.
Okay.